Welcome to your video on Cramer's rule, which is the last method in order to solve a system of equations using matrices. So we'll get started here by just giving you a little refresher about what the three methods actually are so far that you do know on how to use matrices and how to get x equals, y equals, or z equals if you're solving a 3 by 3. So the first one is row operations to get this wonderful ref. All right, that was the button in our calculator that we were able to put the matrix C in and then use ref to figure out what the x, y, and z were equal to. Probably the easiest way of all the methods. The next method was our matrix algebra that we use in our matrix equations, where we took our inverse of our A, multiplied it by B to get our x, y, z as we were going through. Now, this last method is something called Cramer's rule. It has a couple of rules very similar to the matrix algebra, where we can only use this for square matrices. So now, just think about both of these two examples. They can only be used when you are dealing with square matrices. So here, if you have any other type of matrix besides a 2 by 2, a 3 by 3, a 4 by 4, then your only option is the very top one, to use the ref in your calculator. But when you have square matrices, these are other methods that still work, right? Instead of, like with number 2, we were using inverses. Now we're going to use something called a determinant as we go through. So actually, that's how we're going to get started here. A determinant is a numeric value associated with the coefficients of the variables in a system of equation. And it actually is going to be something that you might seem a little familiar with, because again, we can only use this with square matrices, and the determinant is going to have two different ways to actually write this out. The first one is just the DET, and when we get to our calculator here in a little bit, you can see that's the button that we're going to be looking for, the function of our calculator that we're actually looking for. Or if you see this kind of absolute value looking thing around your A, when you're dealing with matrices, that does also mean a determinant as well. Now, the key here is that this might look a little bit confusing, but on the left-hand side is just what a basic equation would look like if you were given a 2 by 2 equation leading into a 2 by 2 matrix. So the equation turns into our A, B, C, D, and all that this means is this equation is your determinant equation. Okay, it is your AD minus BC. Now you may be looking at that saying, that's a little bit familiar. That was a part of our inverse equation that we used when we were practicing with inverses, and you are 100% right. Okay? They do have some overlap between there, and that's why this equation should hopefully be a little bit easier for you to go through. So now the big thing as you're looking through is the next question is asking you to actually find the determinant. This is going to be a really important part for the process of actually using Cramer's rule. So now when you're finding your determinant, notice how this is a 2 by 2. Your determinant, just like what we have, has just the A, the B, the C, and the D. Or you're just dealing with the numbers in front of the X, the number in front of the Y's in both of the equations. For our regular determinant, we do not care about E and F. We don't care about the numbers that are after the equal sign. So our matrix that we're essentially creating is just going to be, for our example, a 3, a -2, a -6, and a 1. And when we actually go through the determinant, now we have our AD minus our BC, or we have our 3 times 1 minus, and then our next 2 piece of information, our -2 times our -6. So we get a 3 minus, and then we get a positive 12 in this case, or our determinant is a -9. Right? So mathematically, algebraically, that would be how we would find the determinant of a 2 by 2 matrix. So now we're going to use this skill as we go through. We're going to show you an example with 2 by 2, and then we'll make it a little bit bigger and go into a 3 by 3. So the key here is using Cramer's rule. Notice this first thought that you have, the regular determinant, is no different than what you just calculated. It is just the numbers in front of your x's and your y's. All right, that is going to be the first step that we are trying to do here. The next step is finding the determinant with respect to x. So now notice here, there is the a values that we would normally have in front of our x. they are not in this matrix anymore. So the x's are actually replaced in our matrix by our constants that we have. So in order to help solve for what the x is, we actually have to get rid of the variables and the coefficients in front of those variables. Now we are also going to have to solve for the determinant with respect to y. So when we write this matrix, our y's are going to be replaced, and they're going to be replaced by the constants in that spot. So notice how in the d of x, the y's are still there. Notice how in the d of y, the x's are still there. So it's going to kind of test your organizational skills within each problem. And there is something else that can show up. If you, as long as you, do not get a determinant with respect to 0, then in order to actually solve for x, or to find the value of x, you take your determinant with respect to x and divide it by your determinant. In order to solve for y, you have to take the determinant with respect to y on top and then divide it by your determinant. So you're going to use these numbers to actually get you the answer for x, and to get you the answer for y, or z if you have a 3 by 3 matrix. So now I kind of mentioned the d equals 0 part. If you get a determinant that's equal to 0, you have either a no solution or an infinitely many solutions. For our sake right now, we're not going to get too far into that. The goal is that you are going to get some nice numbers to work with here. Right? So you will need your calculators handy here, especially if you just need to do some calculations. So notice how we have a 2 by 2 matrix. We need to set up our determinant. We have to set up our determinant with respect to x. We need to set up our determinant with respect to y. So the very first one that we want to do is just our regular determinant. This has the x's in there and our y's. Those are the numbers that we're trying to figure out here. And actually now, once we have the 2, the 3, the 9, and the -7, we can now do our determinant. So we have our a times d minus, and then we have our 9 times 3. We have our -14 minus our 27 in this case, or our regular determinant is equal to a -41. Right? Don't worry it's negative. Don't worry that it's a bigger number. All is good. So now we need to do the same thing with our determinant with respect to x. When we have our determinant with respect to x, now the only numbers we're putting in here are the y's and the constants that we have. So the y's have to go in the exact same spot that they normally would. So we have a 3 and a -7. But in place of the x's, we are putting the two constants that we have with the first equation and with the second equation. And now we can organize our AD just like we typically would, 2 times -7 minus, and then our 3 times 50. So you have a -14 minus our 150, and this determinant is equal to a -164. Right? Same process now for the determinant with respect to y in this case. And notice that with the y, we're still going to have our x's in the equation. And then in place of the y's, we're going to put our constant. So our x's have to be just like what we started with in the very first equation, our 2 and our 9. But now, in place of the y's, are going to be the two constants that we have, the 2 and the 50. So if we continue on through, we have our 2 times our 50. We subtract now the answer that we get with the 2 times the 9. We get a 100 minus our 18, or we come up with this final answer to be just a regular positive 82. So once you do those calculations, our goal now is to, in some way, shape, or form, use those to find x. Use those to find y. So our next step now would be to actually calculate what x is. So we take the determinant with respect to x, the -164, divided by our actual determinant. We figured out that all of those, when we divide those together, would get us an answer of x equals 4. We can do the same thing with the y's. Take your determinant with respect to y, divide it by your determinant, and now all of a sudden, you get your y that's equal to -2. So your final answer is just a regular old 4, comma, -2. And notice you were able to solve this 2 by 2 equation using a different method fairly easy without a whole lot of calculations at all that you had to go through. Okay? So the next step here is there's another problem. Okay? I'm going to walk you guys through the beginning, and you're going to do the calculations to see if you can get it. All right? First thing you have to do is your determinant with respect to x, determinant with respect to y. What I would recommend is you pause video. Okay? I will be putting the work in here so you can see it, so you kind of check yourself to see if what you do is correct or what you do is wrong. So feel free to pause it this time. Right, hopefully you paused and gave that one a shot, because what I am filling in now are each of the determinants that you have in addition to what you should have gotten for each one of those answers. So your regular determinant, you should have gotten a -3. Your determinant with respect to x, you should have gotten a -11. Your determinant with respect to y, you should have gotten a -2. So your final answer should have been an x that was equal to an 11/3, and your y that was equal to a 2/3 for your final answer. So again, if you did not get those, feel free to check over each one of your matrices, and if you didn't get that particular number for each determinant, check your multiplication, check your addition, check your negative signs you're going through. So the next part now is going to be evaluating the determinant of a 3 by 3. And before you start to figure out, oh boy, 3 by 3, this means there's going to be a lot of work to show. Well, no. Because we had a rule that any 2 by 2 that you had, you would have to use your brain. You'd have to do all the work on your own. But as soon as you get to that 3 by 3, you can utilize the tools that your calculator actually gives you. So let's actually put this matrix into our calculator. So I'm grabbing my calculator. I have to go to my matrix button, and I'm going to put that into the edit spot, and I'll just put it into my A in this case. I already have a 3 by 3 as I'm going through, and I need to put each one of these in now. 1, 1, 0. Going down to the next row, I have a 0, a 2, and a -1. And I have a 0, a -3, and a 5. Right? And now, just like you normally would do, you would quit that, and now we're going to go back into that matrix button. And the nice part is, when you go over to the math section, the very first thing that is staring right at you is the determinant. If you click enter to that, the calculator is asking you what you want them to take the determinant of. So now we have to go back into our matrix. I put mine in spot A. You click enter, and this should be a 1-number answer that your calculator gives you. So it automatically told you that the determinant in this case was just a regular old 7. So all that you would have to show me in this case is that you put it in your calculator and you got the regular determinant to be equal to 7. Right? That is one step in this process. And you may say, well, how much bigger is the process going to get? Well, if you look at the last part of your notes, we're going to use this Cramer's rule to solve for this 3 by 3 matrix. So you'll notice here that we have a d, we have a d of x, and d of y. We're also going to have to go with our d of z. I'm going to just make myself a little room here so I can fit that last piece of information in here. And I'm going to put in here my d with respect to my z, so we can make sure that that is ready to go as well. So now the goal is, because this is a 3 by 3, we get to use our calculator for this entire thing and utilize your calculator, because it's going to make your life quite a bit easier. The key is setting up each one of these matrices, which I have to see. Okay? And when you're showing me your work, I know it's all going to be in your calculator, but I have to know what you put into your calculator. So for your regular determinant, well, piece of cake, it's just the x, just the y, just the z. So I have a 1, I have a -1, and a 1. I have a 2, a -3, and a 4. I have a 5, a 1, and a -2. And I'm going to put that in my calculator right away and find out what that determinant actually is. So I'm going to go back to my calculator. I have to go back into my matrix here. And again, you can put it on whatever one you want. I'm going to go to the edit spot. And I then do have a 3 by 3, so all works out fine. I'm going to put in my 1, my -1, my 1 in that case. I'm going to put in my -4. Sorry, wrong spot there. So I got the wrong thing. I have a 2. I have a -3, and I have a 4. I have a 5. I have my 1, and I have my -2. Again, always good to double check to make sure that you put everything in correctly, so that when you do the determinant, all's good. So now we quit out. We go back into the matrix. I know that my math button is what I'm looking for, and I have my determinant that actually shows up. I go back into my matrix so that I can put in my actual A spot, close my parentheses off, and now I have what the determinant is actually equal to, which is just a regular old 5. In this case, don't forget the -5 as well. So we now know that this determinant, just the regular determinant, is a -5. So what I'm going to go through is I'm going to help identify what each of the next matrices should look like, and then I'll give you the option to pause, go through, put them in your calculator, and make sure you get each one of these to work out. All right? Your determinant with respect to x means that you are not going to have any x's, but your y's and your z's are all going to be the exact same. But in place of x, you're putting your constants. So I have a -4, I have a -15, and I have a 12. Right? Now we're looking at the determinant with respect to y. The x's are going to stay the exact same from the start. So we have a 1, a 2, and a 5. The z's are going to stay the exact same from the start with a 1, a 4, a -2. And in place of the y's, we are going to have our constants, our -4, our -15, and our 12. And we can continue on now by putting our determinant with respect to z. So that determinant with respect to z is going to have the exact same x's to start, the exact same y's to start, but in place of the z's, now you're putting each one of the constants that we have. So this is where I recommend pausing the video, going through, finding the determinants of each one of these spots. This time, hopefully you have paused and tried this on your own. Your determinant with respect to x, you should have received a -5 for that one as well. Your determinant with respect to y, you should have received a -15. Your determinant with respect to z, you should have received a 10. So that means to solve, our x is going to be a -5 divided by -5. Your determinant with respect to x divided by your determinant, or your x is 1. Your y, in that case, would have been your determinant with respect to y, -15 divided by -5, or 3. Your z, in that case, would be your determinant with respect to z, which was a 10, divided by -5, and you would have gotten a -2. So your final answer would be a 1, 3, -2. So you have now seen the third and final method on how to solve a system of 3 equations by using Cramer's rule and what is called a determinant. Good luck with your practice.